Well, now we're going to talk about the nature of roots, okay, of quadratic equations. Note that for quadratic equations, the root is determined like we call it delta. The discriminant delta is b squared minus 4ac. Sometimes if delta is greater than 0 and a perfect squared, perfect squared, I don't know, just trying to make a perfect square. Then we can say the roots is rational. Sorry, the root will be rational, and because the maximum number of roots in a quadratic equation we can have is 2. Okay, so in situation like this, the roots are rational numbers, and they're unequal. Okay, they're unequal and they're rational. But now if delta is equal to 0, then the root is unique. Okay, and rational. Say I'll say here is rational and unique. And then if the discriminant delta is lesser than 0, then the roots is the roots are non-real. Okay, they are non-real here. Now over here, if they are it's greater than 0, but it's not a perfect squared. Okay, I need to add this condition. Maybe I can just write it above there. Let's say if delta is greater than 0, but not a perfect squared. Okay, not a perfect squared, then we say it is irrational. The roots are irrational, and they are also different. Okay, they're also different. Now, let's answer this question here. By looking at question A, for instance, I can work out the discriminant. Okay, so we can say for A, for instance, for question A, delta will be equal to b squared minus 4ac. Now look here, b is 1 minus 4, a is 1, and then c is 1. Okay, and then this makes what? 1 minus 4, and this is equal to -3. So because it is -3, okay, it's lesser than 0, we can say here is non-real. Non-real. Non-real, I think, yeah, real, yes, like that. That was question A. For B, we have like x squared equal to 2x, 2 open brackets, x plus 1. I'm not solving it, but I just need to write the standard form of quadratic equation. That makes equal to 2x plus 2. And if you move everything to the left-hand side, it's going to be x squared minus 2x minus 2 equals 0. Now we can work out the discriminant delta. Delta would be equal to b squared, so -2 squared, which is 4 minus 4. A is 1, and then c is -2, and then that makes 4 plus 8, which is 12. 12 is not a perfect squared, so over here we'll say that the roots are real, okay, and then an equal. There will be an equal. I can also say rational. If I say rational, I don't need to say real again. Or I can just say, I can say rational. Okay. That's when I come. They are rational and unequal. Because 12 here is positive, and then it's not a perfect square. Okay. So there are two roots here. It will generate two roots, two unequal, and oh la la, I'm saying rational. Sorry, I meant to say irrational. Two unequal, irrational here. Okay. Now for C, um, we have like x squared equal to 4x. Now, which means x squared minus 4x equals 0. Here, delta would be like b squared minus 4. You see, b is negative 4. Negative 4 to the power of 2 is 16 minus 4. A is 1, and then c is 0. So this is just equal to 16. And then 16 is positive, and then it's also a perfect squared. Okay. So we can say here that C is rational, um, um, and unequal. Okay. So we can also do question D. This is like negative 2x squared minus 16x minus 32 equals 0. Okay. I prefer to reduce this. We take negative 2 for common factors. Okay, I'm not solving the problem, but just make it easier to solve. That's going to be like x squared plus 8x plus 16 equals 0. Now, the discriminant delta will be equal to b squared, so 64 minus 4 times 1 times 16. That makes 64. 4 times 1 times 16 is also 64. And then this is equal to 0. This is when delta is equal to 0, this is the condition to have like only one real root. So here we have like one rational root. So it's rational, and then unique. Okay, unique root. This is for unique or equal. I can say unique or equal roots. Okay, and then you can also do E. E has x minus 2, and then 2x minus 1. Ça fait comment? 2x minus 1 equal 5. And then we can times here like that, and then what we got is 2x squared minus x, sorry, 2x squared minus x minus 4x plus 2 equals 5, and then that makes like 2x squared minus 5x, and if I move the 5 over, it can be like negative 3 equals 0. Now we can work out the roots. The discriminant delta will be equal to b squared, so that makes 25 minus 4, a is 2, and then c is negative 3, and that makes negative 25 minus 24, no, plus 24. That makes 49, okay? 49 is positive and then also a perfect squared. So in this case, we say that E is rational and unequal. Okay, the roots are equal only when the discriminant delta is equal to 0. We can also do F, which is given by 3x plus 7 equal to 5 over x. So if we times the whole equation by x, this will be 3x squared plus 7x equal 5. If we move the 5 over, that makes 3x squared plus 7x minus 5 equals 0. Okay, now we can find the discriminant delta by doing what? B squared, which is 7 squared, 49, minus 4 times A times C, which is negative 5. That makes 49 plus, okay, because negative quickly makes positive. 4 times 3 is 12, 12 times 5 is 60. This makes 109, and then 109 is positive greater than 0 and is not a perfect squared, okay? So we can say here that this is irrational, okay? Irrational and unequal, okay? Thank you. Well, we've read the question here. The question says that show that the roots of the equation nx open bracket x minus 4 equal negative 4m are equal to all real values of m. Now, we times here that it will make like mx squared minus 4mx. And if I move the negative 4m over, that makes negative 4, positive 4m, okay, equals 0. Now the question says, show that the roots of the equation are equal for all real values of m. So the roots is given by, we need to find the discriminant delta, which is given by b squared minus 4ac. Okay, so delta will be b, here b is 4m, okay, 4m to the power of 2 minus 4 times a, which is m, and then c is 4m also. So delta will be like, that makes 16m squared minus 16m squared, which is equal to 0. You know, when the discriminant is equal to 0, this implies that uh, the roots are equal. Okay, this is the condition. You know, that it says that if delta equals 0, then roots are equal, okay? Roots are equal, so it's proven. Question 3 says that show that the roots of the equation, this equation, are non-real if m is different than 0. Now, if we work this out, this will be equal to, that makes x squared minus 3mx plus 5m squared, okay? So the discriminant delta, you know, this is equal to b squared minus 4ac, okay? So we can just note that delta will be equal to b is 3m, 3m to the power of 2 minus 4a is 1 and c is 5m squared. This will make like 9m squared minus 20m squared. Now this is equal to negative 11m squared. The fact that the discriminant here is less than 0, we can say that they are it is not real, okay? Because they had the condition. The condition is that if delta is less than 0, Then we said non-real, non-real. Thank you. Here, the question says, show that this expression here are rational for any real value of a where a is different than 0. Now, if I do a, for instance, 2x squared plus ax minus a squared equals 0. Now, we're going to work out the discriminant. The discriminant delta equal to b squared minus 4ac, okay? So, we do delta equal to b squared, so a to the power of 2 minus 4 times a, and c is a squared, negative a squared actually, okay, negative a squared, negative a squared, and then this will be delta equal to a squared minus actually plus 8 a squared, delta equal to 9 a squared. 9 a squared is obviously um, positive or greater than 0, and the fact that 9 is a square number, uh, um, and then 3a squared makes a perfect square because it's going to be like 3a to the power of 2 is a perfect squared, then we can say therefore this is a rational number because that's the condition. The condition says that if the discriminant is greater than or equal to 0 and is a rational number, is rational, then actually, I mean, not rational, I meant if it is greater or equal to 0 and a perfect squared, okay, a perfect squared, then you can say the roots are rational. So here the roots are rational. Okay. This says that discuss the nature of the roots if a equals 0. So if a was equal to 0, the discriminant here that be the discriminant delta would have been equal to 0 also because it's going to be like 3 times 0, uh, or let's say 9 times 0 squared, which is equal to 0. And if it's 0, then the discriminant will be rational and there will be only one solution. That's what the condition says. So it's going to be like if delta, it says that if delta equal 0, then one solution, and that solution is rational. Or we say one solution, or we can say equal solutions, okay? Equal roots, equal roots, equal roots, and that root is rational. Thank you. Say show that the roots of the equation, this given equation is are rational for any value of b. Now, we know that delta is b squared minus 4ac, and then roots are rational if they are greater or equal to 0, okay? And also, that's what the first condition. The second condition is that they form a perfect square, okay? So now, when I say here, delta will be equal to b squared, so it's going to be like b minus 2. B is because this is the form of quadratic equation, okay? Ax squared plus bx plus c. So b here is p minus 2 plus the power of 2 minus 4. A is 1, and then c is 1 minus p. Then this will make what? P squared minus 4p plus 4, okay? And then that makes negative 4 times 1, that makes negative 4. And then negative 4 times that makes also positive 4p. And then we can simplify here, negative 4p, positive 4p, 4, and negative 4. And then this is equal to p squared. Delta equal to p squared. Then um, this is p. Okay, we said this first of all. This p squared here can be greater, can only be greater or equal to 0. Okay, it cannot be negative. This one cannot be negative. It's always positive or equal to 0. Now, this fulfills this condition here. So therefore, we can say are rational. Okay. Okay. Regardless of the value of p raised to the power of 2. If it's 0, it's going to be 0. If it's a negative number, it's going to be positive because it's to the power of 2. If it's a positive to the power of 2, still going to be positive. Okay. So this is always greater or equal to 0. Then this is the proof that it can be rational for any value of p. Okay. Question 6 says that show that the roots of the equation are real for all values of r. So we see that delta, the discriminant is b squared minus 4ac, and then this is like ax squared plus bx plus c. Okay, we're going to move the r over. Okay, so let me c will be like 1 minus r. So uh, if you move the r over, it's going to be 1 minus r. So delta will be equal to uh, b squared. So it's going to be like 4 to the power of 2 minus 4a is r plus 1, and then c is 1 minus r. Then this will make what? 4 squared. 4 squared is 16. Okay, minus 4 r plus 1 times 1 minus r. This this is like the form of the product that leads to a difference of two squares. So this makes like r squared minus 1 squared. Okay, and that makes what? 16 minus 4r squared minus 4, no, plus 4. Um, and that makes uh, negative 4r squared plus 20. Okay, now uh, um, not really right here because I was supposed to say to change here to 1 plus r. Okay, you don't r plus 1 is something else 1 plus r. I do that because I wanted to have a difference of two squares here. So the difference of two squares would be rather 1 squared minus r squared. So this will make like negative 4 then, okay, negative 4, and then positive r squared, and then this will be um, 4r squared plus 12. Now, the fact that this positive 12 will be positive always, and then also this will always be positive, so this will be greater or equal to 0, but this one is strictly greater than 0, okay? Then we can see it will always be real because that's the condition. Because the sum of the two will always be altogether combined will be greater than 0. So the condition for to have like to always have real roots is when the discriminant delta is greater than 0, and then that's the condition we find. Thank you. But now go to the question 7. The question says that for which values of k will the equation x squared minus 5x minus k equals 0 have equal roots, real roots, and non-real roots? Okay. The equation will have equal roots if the discriminants here equal to 0. And to have like real roots if the discriminant is greater or equal to 0 and a perfect square. I abbreviate it like that sometimes. A perfect square. Okay. And then you will have a non-real root if the discriminant delta, okay, is lesser than 0. Those are the conditions. Now let's work it out. Okay. We do know also that delta the discriminant delta is given by b squared minus 4ac. Okay, so in this case, let's record delta. Delta will be equal to b squared, uh, b squared minus 4a, and then c. We can substitute the values. B is negative 5. Okay, 4a. A here is the coefficient of x coefficient of x squared, I mean, and then c is the constant term, which is k, right? Not k, but negative k. Okay, then this will be 25 minus, not minus, but plus 4k. Now, if this is that delta, now if this is equal to 0, this means that 4k will be equal to negative 25, and k has to be equal to negative 25 over 4. Okay, so that's if that's equal root. Okay, equal root delta equals 0. Now, if k then, if now we work for this other case for real root, okay, I'm right here, real root, um, which means delta is greater or equal to 0, and is a perfect square. Okay, so in this case, we're going to say that 25 plus 4k must be greater or equal to 0. Okay, and then that means 4k will be greater or equal to negative 25, and then k must be greater or equal to uh, um, negative 25 over 4. Okay, here k must be those values that are greater than or equal to negative 25 over 4, and that makes delta a perfect squared. Okay, so those are the two conditions. So k, the condition number one is k must be greater than negative 25 over 4, and then also, and that the discriminant here 25 plus 4k must be a perfect squared. Okay, must be perfect squared. Must be perfect squared. And then the third condition, the third question C says non-real roots. Non-real root is like 25 plus 4k must be lesser than 0, which means 4k must be lesser than negative 25. Okay, which means that k must be lesser than negative 25 over 4. If k is less than negative 25 over 4, then this equation will have no real roots. Okay. Another question here says for which value or values of k will the equation, this given equation here, have equal roots? You know, the conditions for to have equal roots is that the discriminant delta must be 0, and then the discriminant, as we said in the previous question, is equal to b squared minus 4ac. Then in this case, we have like k x squared plus 2kx. We can move the negative 3 over, that makes positive 3 equal to 0. Now we can substitute here. So I'll be like b squared minus 4a and then c. Now sub in the values of b squared is 2k, minus 4a is k, and then c is just 3. So this will be delta equal to 4k squared, okay, minus 12k. Now we're going to set this equal to 0, okay? So now to do that, we factorize, we take 4k for common factors, and then if I take 4k for common factor, I'm left with k minus 3. That means k equals 0, or k minus 3 equals 0. Okay. So I said, of course, it is 4k equal to 0. But 4k equal to 0, 4 cannot be 0. It means that k is 0, or k here is equal to 3. So this is the condition to have equal roots. But now when the question here says k cannot be 0, so this case here is not applicable. Yes, so our answer is just k equal to 3. Okay. Now we're going to do question 9 here. The question says that for which values of p will the equation, this equation here, have real roots and non-real roots? Okay. Over here, we know that the equation has here roots if the discriminant is greater or equal to 0 and a perfect square, okay? And then we will have non-real roots if the discriminant is lesser than 0. Now, let's work out real roots. It says that x, open bracket 4x plus 3 equal to negative p. Negative p. Okay, I'll prefer to write my equation here. Now, if we extend this, this will be 4x squared plus 3x. And then if you move the p over, that makes plus p equal to 0. Now, delta, we also, delta is equal to b squared minus 4ac. Now, for this case, I'll say that delta will be equal to b squared minus 4ac. Now, to sub in there, b squared is going to be like 3 squared minus 4a is 4, and then c is p. Now, this will make what? 9 minus 16 p. Now, this must be greater or equal to 0, okay? Greater or equal to 0. I'll move this negative 16p over, that makes 9 is greater or equal to 16p. If I divide both sides by 16, and then I'll get what? If I divide by 16, and then also by 16, I will get 9 over 16 is greater or equal to p. Now, we can reverse the order here. That makes p is lesser than or equal to 9 over 16. Then over here, delta is lesser than 0. This means what? Delta equal to 4ac. Delta will be 4, excuse me, 3. E squared minus 4a is 4, and then that's that, and then this will make 9 minus 16 lesser than 0, 16p, okay, lesser than 0. Now, this will be, if I move the 16p over, that makes 9 will be lesser than 16p, divided by 16 both sides, we get like 9 over 16 greater than p, excuse me, lesser than p. So therefore, p has to be greater than 9 over 16. So well, question 10 says that for which values of k will the equation, this equation here, have equal roots? We know that the equation will have equal roots if the discriminant delta is equal to 0, okay? Delta is given by b squared minus 4ac. Then we write here delta will be equal to b squared uh, b squared minus 4a and then c. Now, I'd like you to be careful here. If you consider this expression, b is the term that ends with x, okay? Remember, the quadratic equation is of the form ax squared plus bx plus c. Now, in this case, here we have like kx, and then, 2kx and then 4x. Now, we can take x for common factor, so it's going to be like x squared plus 2k plus 4x x plus 9k, see, equals 0. Now, this means that b is 2k plus 4, and then a is just 1, and then c is 9k. Now, we can apply our property that says that a plus minus b squared is just a squared minus plus minus b squared, no, a squared plus minus 2ab plus b squared, okay? Now, because it's a plus, we will consider this plus here. Because it's, in this case, it's 2k plus 4. So it's going to be 2k squared will make 4k squared, okay? Plus 2 times 2k times 4b, which is 4b. So note that this is our a and that's b. Plus b squared, which is 4 squared. Okay, that makes okay, minus 4 times 1 times 9k will make 36k. So that makes out 4k squared, okay, plus 2 times 2 times 4, that makes 16k, plus 16 minus 36, minus 36k. Now, these two are like terms. We can combine them. That makes like 4k squared minus 20k plus 16k. Now, to have like equal roots, the discriminant has to be equal to 0. And then when I look at the terms here, they're all multiple of 4. We can divide each term by 4. Dividing each term by 4, we will have that makes k squared minus 5k plus 4 equals 0. Then I'll look at the last term, which is positive 4. I'll write here 4. And then the factors of 4 are 1 and 4, 2 and 2. Then over here, we can write that k, close bracket like that, k, close bracket like that equal to 0. Then over there, I can just make minus 1 and then minus 4, because minus 1 minus 4 makes negative 5. So this means that k has to be equal to 1 or k has to be equal to 4. So this is the solution. Okay. The question says that for which values of k will the equation have non-real root? Non-real root is when the discriminant is less than 0. And then we do know that the discriminant delta is b squared minus 4ac. Now, this equation can be rewritten as x squared plus x plus 2 minus 3x plus k equals 0. Now, this makes what? X squared, x minus 3x makes negative 2x. And then we have like a plus 2 plus k. So now we have like this divisible coefficient. That's what, that's a, and that's b, and all this is c. Then we can write delta as b squared minus 4a c. So that I can substitute the values. Okay, b is just negative 2, a is 1, and then c is 2 plus k. So this will make what? 4 minus negative 4 times 2 makes negative 8. Negative 4 times makes negative 4k. Okay, and then this will make what? Negative 4 minus 4k, and then this discriminant here has to be less than 0 to make a non-real solution. So if I move negative 4 over, that's going to be like negative 4k x must be less than 4. If I divide both sides by negative 4, okay, we need to be careful here. Dividing by negative 4 will reverse the order of the inequality. So this will become like k must be greater than negative 1. Okay. Remember that whenever we times or divide by a negative number, the inequality symbol is reverted. It becomes it's reverted, like lesser than will become greater than will become lesser than. Thank you. Well, we have another question here that says calculate the values of m for which the given equation has one root with a value of -2. Okay, let's start with A. First of all, we do know that the quadratic equations, the root of the quadratic equation is given by -b plus minus square root of b squared minus 4ac all over 2a. Okay. Delta will be equal to b squared minus 4ac. Now, if we're looking for the root that's equal to -2, meaning x has to be -2, okay? Now, let's see. Let's substitute here. It's going to be like -3, negative, let's say, minus b plus minus square root of b squared minus 4ac, okay, all over 2a. Now, let's substitute. Minus 3, 3, 1, 5m. Okay, one day. So this is equal to what? 3 plus minus square root of 9 minus 20m. Okay, over 2. Now, the question says that one of the root must be equal to -2. Now, you can notice that you can see if you can't, okay, for me, for instance, I can see that this has to be equal to this part here in the root here has to be equal to 7. Why am I saying that? Because I know 3 minus 7, 3 plus 7 would be 10. 10 divided by 2 is 5. It's not working. But 3 minus 7 is -4. -4 over 2, it's -2. But in case you don't see it immediately as I do, just call it a variable x, not x here. Let's just say n, for instance. Okay? Because we don't want confusion with the x there. So we're going to call it n. Now it's going to be like 3 plus minus n over 2 equal to -2. So now there is an invisible one here. We can do the cross multiplication, okay? Okay, this will be what? It's going to be like 3 plus minus n equal to -4. So if we move the 3 over, n will be equal to -4 minus 3, and then n will be equal to -7. Of course, you may tell me plus minus here. The plus minus is not that important because it comes from here. We could have just say it's generated by the roots, okay? So it doesn't really matter. I can say it means n equal to plus minus 7. Okay, if I move the plus minus over there. Now, n is the result of this. In other words, square root of 9 minus 20m equal to plus minus 7. Now, if I need to find the value of m, I will raise both sides to the power of 2. Okay, and then the power of 2 will cancel this root, and then this might be like 9 minus 20m. Now, over here, no matter if it is positive 7 to the power of 2 is going to be 49. Negative 7 to the power of 2 is still 49. I'll move the 9 over, it's going to be like negative 20m equal to 49 minus 9. That makes negative 20m equal to 20. Excuse me, 40. And then dividing negative 40, yes, and dividing both sides by negative 20. And then we get m equal to -2. So m has to be equal to -2 in order to have only one root equal to -2. Okay. Now the following question says roots equal roots. Equal roots simply means we're going to make the discriminant equal to 0. So b here equal roots might be like 9 minus 20m, which is the discriminant, equals 0. This means if I move the negative 20 over, so we like 9 equal to 20m, and then we divide by 20 both sides, and this will be m equal to 9 over 20. And then C, the question says that real roots, it means that 9 minus 20 has to be greater or equal to 20m, uh, 9 minus 20m has to be greater or equal to 0. So, which means that 9 must be greater or equal to 20m, which means that 20m is lesser than or equal to 9. Okay, and then dividing by 20, 20 m has to be lesser than or equal to 9 over 20. And okay, this is the value that will make it the perfect, real root. Thank you. Question 13 says that given this equation, now A, for which values of k will the roots of this equation be real? Find one value of k so that the roots will be rational. Okay. First of all, we're going to develop this. It will make 3x plus 3. Okay. And then this will make x squared equal to negative 3x minus 3 plus k. Oh, 3 plus k. If we move, uh, let's do it this way. It's going to be x squared will be equal to negative, no, x squared minus 3x minus 3 plus k. Okay, or x squared minus 3x plus k minus 3 equals 0. So we can also do that. So rewrite this from, first of all, with times here, it takes 3x times 3, and then we move these over, okay? It becomes negative 3x and negative 3. And then here we can just rearrange, put the k first, so we have positive minus 3. Now, for which values of k will the root of this equation be real? And then we know that the root must be real if the discriminant is greater or equal to 0. And the discriminant is b squared minus 4ac. So over here, we just want to make delta will be equal to b squared minus 4a and then c. So we can substitute b is negative 3, 4a is 1, invisible 1 is there, and then c is k minus 3. Now this will be what? 9 minus 4k plus 12, which makes negative 4k plus 21. That's the discriminant delta. And then to be real, it means it has to be greater or equal to 0. Now I'll move the negative 4 over, that makes 21 will be greater or equal to 4k. And then dividing by 4 both sides of the equation, or divided by 4 both sides of the equation makes 21 over 4 is greater or equal to k. Or we can write it as k is lesser than or equal to 21 over 4. Okay? That's question A. And then for question B, the question says I find one value of k so that the roots will be rational. So we already know that it's going to be like, it's going to be real if it's 21 over 4. And then to be rational, it means it has to form this discriminant here has to form a perfect square, okay? So the discriminant is over here, we said it means negative 4k plus 21 must be a perfect square. Now I need to find at least one, so I know that's negative 4k plus 21 must be greater or equal to 0 and must be a perfect square. Now let's see. And I know k must be lesser than 21 over 4. I can see that 21 over 4 is approximately 5 and a quarter, okay? It must be lesser than 5 and a quarter. So now let's substitute here. If I take a number like 4, for instance, if I sub 4 over here, which is lesser than that, I say 4 because it's less than 5 and then quarter. It's gonna make negative 16 plus 21, which is equal to 5. And then 5 is not a square number. I'll change. If I take a number like 3, I say 3 because 3 is still less than that. If I have 3 there, so I'll be like negative 12. Negative 12 plus 21 is equal to 9. And then 9 is a square number. So I can say, for example, k equal to 3. This is one of the examples. Thank you.